Okay, for this problem we have a mathematical induction problem concerning divisibility. I wish to show that 2 to the 2n minus 1 plus 1 is always a multiple of 3. So the proof of this will be by induction on n. And our base case for this problem is n greater than or equal to 1, so we'll start there with n equals 1. And let's check to see if the n equals 1 case works. If n equals 1, I have 2 to the, replacing n by 1 here, I have 2 times 1 minus 1 plus 1. So that's going to be 2 to the 2 minus 1, so that's 2 to the first plus 1 equals 3. And that is certainly a multiple of 3, which is divisible by 3. So the base case works. N equals k. So we now assume that 2 to the 2k minus 1 plus 1 is divisible by 3. So that means I can write that as 3 times some q, where this q that I've defined is an integer. Okay, now I've moved to the inductive step, n equals k plus 1. Okay, so on the left-hand side, I would have 2 to the 2 times k plus 1 minus 1. My target, which I'm going to write in pencil down here just in case I run out of space, is that this is going to be equal to 3 times some other integer, capital Q. So if I can show that, and I forgot the plus 1 here, I apologize. If I can show that this plus 1 is equal to 3 times some integer, capital Q, then I'm done. Alright, so let's get to it. So if I expand this out, I get 2 to the 2k plus 1 plus 1. And so this will be equal to 2 squared times 2 to the 2k minus 1 plus 1. And so what I deliberately did was force a 2 to the k minus 1 here because my inductive hypothesis has a 2 to the 2k minus 1 here. Alright, now let me write down an incorrect step. I can't write this as, well, I can't write this as 4 times 3q. That's not permitted. So what's wrong with this is I don't have parentheses there. And so if there were parentheses, then I could do this. But there are no parentheses, and so that's not permitted. And so let me get rid of that because that's incorrect. Okay, so that's a common mistake, to kind of see the 2k to the 2k minus 1 plus 1 and see that there and then just replace and forget about the order of operations. Okay, now what do we do? Well, we notice that if I can solve for 2 to the 2k minus 1 here, that'll be equal to 3 times q minus 1. And so I can substitute that here. 4 times 3 times q minus 1 plus 1. Okay, so let's factor. We get, or multiply out, we have 12 times q minus 4 plus 1. And that's equal to, a factor of the 3 out, I have 4 times q minus 1, because negative 4 plus 1 is minus 3, and so that factors there. And so indeed, I end up with 3 times something. Now, this something is an integer. Q was an integer, multiply by 4, still an integer, subtract 1, still an integer. So that's an integer. And then I can use any standard end of proof symbol to say that I'm done. And so that is my proof by induction that 2 to the 2n minus 1 plus 1 is always a multiple of 3.